Students, welcome back. Here we have some miscellaneous problem. Very interesting problems. Limit x is tending towards 2, f of x minus f of 2, the whole upon x minus 2 exists. Now, my dear students, when you observe that function which is in the question, it is already a definition of f dash of x. That is f dash of 2 in this case. So, we say that by definition, f dash of 2 is limit x is tending towards 2, f of x minus f of 2, the whole upon x minus 2. Students, if you find f dash of 2, it is obvious that f of x is differentiable, and for a function to be differentiable, it has to be continuous at that particular point. So, if f of x is differentiable, so it has to be continuous, and for continuous function, we know the equation, that is the left hand limit and the right hand limit both should be equal. So, limit x is tending towards 2 minus f of x should be equal to limit x is tending towards 2 plus f of x, and hence option B is the correct answer. Moving ahead. Limit x tends to a f of x upon g of x exists if. My dear students, when you see this, you have revised the things. Yes. Any of you answered already. This is already an theory question of algebra of limits. You remembered something? No? No problem. Here we have. By the definition of algebra of limits, if f of x and g of x be the two continuous function at a point x equal to a, then f of x upon g of x is a continuous function at x equal to a, provided g of a should not be equal to 0. So I can say only f of x will exist at x equal to a and when g of a is not equal to 0, and hence option B is the correct answer. Here in this case we have n is tending towards infinity, but in the numerator we have a series, that is 1 plus 2 plus 3 up to n. We know that 1 plus 2 plus 3 up to n is n into n plus 1 by 2. So the equation would be limit n is tending towards infinity, n into n plus 1 by 2 into 1 upon 3n square. So keeping 1 by 6, and it would be n into n plus 1 by n. As a result, limit n is tending towards infinity, 1 by 6 into your n and n gets cancelled, and the equation would be 1 plus 1 by n. In this case, n is tending towards infinity. So as a result, 1 by infinity is 0, and hence 1 plus 1 by infinity, since you have 1 by n, and the equation would be 1 by 6 into 1 plus 0, which is nothing but 1 by 6, and hence option C is the correct answer. Moving ahead. If a function is continuous at x equal to 0, where function is x into sine of 1 by x, you need to find the k for x equal to 0. All of you are very sure that when x is tending towards 0, sine of 1 by x, shall we write that x as 1 by x? So, whose answer would be 1, right, according to you? No, it is incorrect. Sine of 1 by x upon 1 by x when x is tending towards 0 is not equal to 1. Why? We know that limit theta tending towards 0, sine theta by theta is equal to 1 only when the theta in all cases remains theta. Over here, if you see, the theta in the function is 1 by x, but while applying limits it is only x, and hence it is incorrect. So now let's go for the solution. F of x is continuous at x equal to 0, then f of 0 is equal to limit x is tending towards 0 f of x. We know this already. So we can write that k k is equal to limit x is tending towards 0 f of x, and which is nothing but x into sine of 1 by x. But we know that sine function ranges only in between -1 to +1, and hence as we are requiring x into sine 1 by x, we are multiplying by x throughout. Hence the value would be -x is less than or equal to x sine of 1 by x, which is less than or equal to x. And as x is tending towards 0, the value would be 0 less than the given function, which is less than 0. And hence we get value of k is 0, and hence option D is the correct answer. Moving ahead, you have a function, it is continuous at x equal to 2, and you need to find the value of a. If f of x is continuous at x equal to 2, limit x tends to 2, f of x is already 2 in the question. Therefore, limit x tends to 2, x square minus a plus 2 by x plus a the whole upon x by 2 should be equal to 2. At x equal to 2, denominator is 0. Therefore, for f of x to exist, numerator has to be 0, and hence limit when x is tending towards 2, x square minus a plus 2 into x plus 4 should be equal to 0. So, as you put the value of x, it would be 4 minus of a plus 2 into 2 plus 4, which is equal to 0. And while opening the bracket, it would be 4 minus 2a minus 4 plus 4 plus a, which is equal to 0. 4 and 4 getting cancelled, and the equation or the value of a which you get is 0, and hence option C is the correct answer. All the best for your exams. Thank you.